Hi, today we are going over section 6.1, which deals with geometric sequences. Geometric sequences are sequences in which we multiply by a specific number or ratio to get our next number. So for example, 2, 4, 8, 16, 32, 64 would be a geometric sequence. Now, an infinite sequence has an unlimited number of terms and continues forever. In most cases, we cannot calculate the sum of an infinite sequence. There is some situations where we can. We'll get into that later on. We also have finite sequences. So these have a set number of terms. So these ones, not only can we figure out what terms are in them, but we can also add up all the terms in it. So in this unit, we'll go through a variety of formulas. The first one is our term equation. So to get a specific term in a geometric sequence, we use the formula Tn, or T subscript n, is equal to T subscript 1 times r to n minus 1, where T subscript n is our nth term. So for example, if we had T subscript 9, that'd be our 9th term. T1 is our first term. R is our ratio, so what we're multiplying our term by to get our next term. And then n is our number of terms. So for example, write the general term equation for 2, -8, 32. So first thing we want to do is get our ratio. To get our ratio, we just divide two consecutive numbers. We take our second number, divide it by our first number. So -8 divided by 2, so our ratio is -4. Now our 2 is our term 1, because it is our very first term. Now to get a ratio, we could have also done 32 divided by -8. It'd give us the same answer. So when we're writing out our general term equation, we're not solving, we're just filling out as much as we can from our term equation. So we've got Tn is equal to T1 times r to n minus 1. So we don't have a specific term number we're looking for, so we'll leave as Tn equals T1, which is 2, times our ratio of -4 to n minus 1. So this would be our general term equation for this sequence. Now, if we want to say our 7th term, we just substitute a 7 in for this n and solve to get our 7th term. So that's essentially what we're going to do here. We want to find our 8th term, so we'll use that equation we just created. So we've got Tn is equal to 2 times -4 to a power of n minus 1. Now, 8th term, that means our n is 8. So we're looking for term 8. So we've got 2 times -4 to the 8 minus 1. So that gives us term 8 is 2 times -4 to a power of 7. Which gives us term 8 is equal to 2 times -16,384. Multiplying those out, term 8 gives us -32,768. Okay, we'll look at some more definitions. So we have convergent sequences as well as divergent sequences. Convergent is when our terms get closer together and move closer to a specific number. Now, this typically occurs when our R value is between -1 and +1. We have divergent, which is when terms move away from each other. Now, this typically occurs if our R value is greater than 1 or if it's less than -1. Okay, so this example, determine the 10th term of 64, 32, 16, and is it convergent or divergent? So we can see 61 is our T1. To get our R, I'm just going to take the second term, divide by the first term. So our R is 1/2. And then we've got 10 terms, our N is 10. So we have our general equation. So Tn is equal to T1 times R to N minus 1. So we're looking for the 10th term. So T10 is equal to term 1, which is 64, times our ratio of 1/2 to a power of 10 minus 1. So that gives us T10 is equal to 64 times 1/2 to a power of 9. So that gives us T10 is equal to 64 times 1 to the power of 9 is 1. 2 to the power of 9 is 512. We'll multiply these together and reduce to lowest term. So we've got T10 is equal to 1/8. Now we can see these numbers are getting closer to each other. So these were 32 apart, 16 apart, and in total, our series gets closer and closer to 0. So this would be a convergent sequence. Now, to determine the ratio, if we don't have two consecutive terms, we enter the values we have into separate equations and set up as a ratio to solve for R. So we'll do an example of this. In a finite geometric sequence, we're given term 2 is -21 and term 5 is 567. We're going to determine T1 and T6. And we're also told the last term is 45,927. We want to know how many terms there are. Okay, so we'll call this first part A, this part B. So working on part A, we're going to come up with two separate term equations. So we've got Tn is equal to T1 times R to N minus 1. So first term they give us is term 2. So we've got -21 is equal to T1, which we don't know, times R, which we don't know. And then our N is 2 minus 1. So we've got -21 is equal to T1 times R to the power of 1. So we'll just read as R. Now we'll do the same thing for our second term. So we've got Tn is equal to T1 times R to N minus 1. In this case, our term 5 is 567 is equal to term 1 times our ratio, which we don't know, to a power of 5 minus 1. So that gives us 567 is equal to T1 times R to the power of 4. What we'll do now is set these up as a ratio. And whichever one has our highest exponent, we'll put on top. So this one has our higher exponent. So we have 567 T1 r to the 4. Below that, we'll have our negative 21. We'll have T1 r. Now 567 divided by negative 21 gives us negative 27. Our T1s are going to cancel out. R to 4 divided by r would be r cubed. So now we'll take the cube root of both sides. So we have negative 3 is equal to r. What we can now do is take this equation and this r value and solve for T1. So we've got negative 21 equals T1 times negative 3. Divide both sides by negative 3. And we have 7 is equal to T1. So we found T1, now we want to find T6. So we have our term equation, so Tn equals T1 times r to the n minus 1. So we want to find T6, so T6 is equal to T1, which was 7, times our ratio of negative 3 to a power of 6 minus 1. So we've got T6 is equal to 7 times negative 3 to a power of 5. So that gives us T6 is equal to 7 times negative 243. Multiplying these out, T6 gives us 6,561. Okay, so now on to part B. The last term is 45,927. How many terms are there? So essentially, we still have our Tn equals T1 to r to n minus 1. So we have 45,927. It's equal to T1, which was 7, times negative 3 to n minus 1. We'll divide both sides by the 7. And we gradually want to rearrange and solve for n. So if we divide both sides by 7, that gives us 6,561 is equal to negative 3 to the n minus 1. Okay, at this point, we'll utilize logarithms to solve. So we'll take the log of both sides. We've got log of 6,561 is equal to log of negative 3 to n minus 1. We will utilize our log laws to move the n minus 1 to the front. So we've got log of 6,561 equals n minus 1 times log of 3. We're going to change it to positive 3 because what we learned in the past, we can't take a log of a negative number. Now we'll divide both sides by this log 3 to get n minus 1 on its own. So we've got log of 6,561 over log of 3 gives us n minus 1. So that gives us 8 is equal to n minus 1. We'll add 1 to both sides. So we have 9 terms total.